Thanks you guys for coming. A lot of people at the last talk. Nice. Okay, I think it's time to start. It's going to be the quick, small talk and take 20 minutes. Just, I guess, the last talk of the day, last talk of the conference. And thanks you for coming and not going home, like, for some reason. Okay, my name is DANIIL POPOV, and I'm a software engineer in both technology. You might already use our scooters or bikes here in Berlin or in many other cities and countries we operate in. And probably you already saw me on the first day of the conference. I was giving talk about the DEX file. But today we're going to cover more high-level stuff than DEX files. And let's start with this simple example, simple piece of code. Have you noticed any problems here, or does it just look fine? I guess from first glance it looks fine. But what if I say that some of your third-party library, of some library or your module will do the following thing, like set up internet connection or open database connection or send some analytics that's supposed to be unique, or allocate some piece of memory, some cache, I don't know, like Dagger graph, large Dagger graph, I don't know, start another process, start too many threads, I don't know. So like when you initialize some library, initialize some module, you cannot know in advance like what's going on there and what things might happen when you initialize something. So when we initialize something and create an application, anything like can happen, unfortunately or fortunately, I don't know. And many other things. And usually we don't care about this too much because we used to think that application class is like a singleton. Oh, sorry, not this singleton, this one. Yes, and so we have only one instance of this class, and that's it. And we might rely on this behavior, like thinking that everything was initialized only once and nothing to care about here. But what if I told you that it's not always true? That we might have some 2 or even more instances of application class. So you might think it's some kind of imaginary scenario, but actually many months ago, or even a couple of years ago, I was fixing very strange bug. I have the following stack trace, and I see no entry even with from my application. And the only thing that looks weird here was like this code 5, and that's it. And I Googled a little bit, find the official documentation for this SQLite, and noticed the following description of this particular error. And I see there is some kind of concurrent activity with some database connection. I spent 2 or 3 days trying to understand where do I have this concurrent access to the database. Like, I didn't figure out. But then I noticed one more thing here in a separate process. So this error might occur when you're trying to access the single database file from different processes at the same time. So SQLite in this case not supposed to be thread safe because it's not thread, it's separate processes, not threads. And the following things actually was happening there in that bug. So for some reason, I had more than one process, and every process was trying to establish the connection to the database. But as you might know, SQLite is just a single file, and when many processes try and read this file or write this file at the same time, something bad might happen. And that was actually happening. Error code 5, that's it. And I started to figuring out why do I have more than one process? We never implement anything in separate processes. We have like very simple application there, and I don't know like why do we do this? Why do we have this? And the thing is that when you typically create application in Android, you always use some libraries, right? You don't have only Android framework and that's it. You use Room, I don't know, retrofit, Android X libraries, navigation, etc., 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 and some third-party libraries. And as you might know, all these libraries might have their own Android manifests because they may declare some permissions there, some services, activities, like whatever they want to declare. And when your app is being built, all these manifests are merged together, and here we have this boom. Because, where is the boom? Oh, yeah, here it is. So, why? Because some third-party library might introduce some Android component, which may want to run on a separate process. So if you open the Android Studio and open your Android manifests and open your Android manifest from the app module and open the merged manifest tab at the bottom, you might see this like really large Android manifest, and every color here means that this particular lines was merged from some library you like depends on. And here's the problem. Like back in the days when I trying to figure out what's going on with database connection. And so, as you know, we have like 4 Android components: activities, services, activities, oh my god, services, content providers, receivers, and activities, yes. And when you declare those components in that manifest, you can provide this tag process and name, and put the name there, name of the process you want to this component be run on. So, for example, you might have some activity or service that would run on a separate process. Not thread, but separate process. And that's a valid thing for Android, so why not? So, when you run such component, launch such activity or run such service, the next thing happened. Zygot is forking itself, creates a new process for you, and you have their instance of application class on create is called. And that's happened when user like launch your app from the launcher. But when your app tries to open such activity or such service which is supposed to be run on a separate process, these things happen again and again. For every process, there is an application class instance and the onCreate method will be called for every instance. So technically, Android application instance is still a singleton, but within a process. And if you are trying to access some shared resources like files or internet connections or shared preference, I don't know, anything, here the problem occurs. So technically within the process it's a singleton, but when you touch some external things, obviously there is a problems. And if we return back to some slides, there is a much more clear picture there. So for some reason I have 2 processes and I established connection to database in onCreate method and I get this error. So how to fix that? Do you have any ideas? I had no ideas at the time also. And let's talk a little bit about the process names. So your main process, usually you have only this one, is called by your package name, like in this example, com.android.sample. That's it. But when you create some activity, service, or content provider that's supposed to be run on a different process, this process tag value from the manifest is concatenated at the end of this package name, and you have this following like names for these secondary processes. And here's the idea. If we can somehow capture the name of current process and compare it with the package name, if they are equals, that means that we are on the main primary process. We can initialize something, build Dagger graph, allocate memory, establish connections, whatever we want to do. But if it's not, it means we are on some secondary process, and we should skip these initializations, connections, and etc. So how to obtain name of the current process? Actually, if you have the Android P or the following versions of Android, there is like already get process name for you. It's like simple method, you just call it and get the process name of the current process. But if your application runs below Android P, you have to do a little bit more to obtain the name of your process. So what can you do? Actually, I have this read process name function. What does it do? First of all, we got the process ID as a parameter, because we know this process ID, we can obtain name of this process by this ID. First of all, we do some sanity check, just in case if P is less than 0 for some reason. And then we read some special file, which is called /proc/yourpid/cmd_line, and the only content of this file is just the name of your process. That's it. And you read this file, trim it, because in the end it had a lot of null, I mean like 0 bytes, and so without it, the string is just the name of your current process you run in. And that's it. We get this name, and now we can compare this name with the package. And if these strings are equal, that means we are running on the main process of our application, and we can now safely build Dagger graph, allocate memory, establish connections, sending analytics events, and everything is fine. So it's our main application process. We can do the things we are supposed to do here. But if it's not, in some else case, you understand that you are some secondary process, and you can do separate initialization if needed, or just do nothing if it's nothing to do there. So it's fine. Now we still have many application instances, but they are on different processes, and it's okay. So the key point from this small talk is just application is still singleton, but within a process. So if you, for some reason, have multiple processes in your application, you would have as many application instances as many processes you have. So just keep this thing in mind, and if you ever face such bug as I faced a couple of years ago, you know what to do. And minute of self-promotion. I've created a couple of libraries for these particular things. And first of all, it's a primary library, which do almost the same as I described it on the previous slides. It just checked if the primary process, then it do some things, otherwise it does another thing. So it allows you to easily understand that you're on a main process or not, and should you do some initialization or you should not do it. And the second library, it's not about the processes, but it's a library, actually it's a Gradle plugin, which allows you to detect unexpected changes in your manifest. So if, how it works, you just create the baseline for your Android manifest, put it in your Git, SVN, whatever you use. And if in some moment in the future you update some dependency version or something like this, and some new activity service or any change sneaked into your final merged manifest, this Gradle plugin will fail your build, so you will be able to see the difference, which library introduces difference and fix it somehow or update the reference. So this library is, again, it's not about the processes, but it's about it's about being aware of what's going on in the final merged Android manifest. So that's it. Here's my Telegram account. You can reach me out there if you have any additional questions. And that's it for today. Thank you.